So today we're going to talk about systems of equations. And systems of equations are where we have two equations and they have two variables, or they could have more than two variables. And we need to solve them to find a solution that works in both equations. So for example, systems of equations typically have the form of ax plus by is equal to c, where this a, this b, and this c are real numbers. So we have two variables, x and y, and we'll have two equations, and we solve to have a solution. And it's not just going to be x equals a number, but it's going to be x equals a number and y equals a number. And you can write your solution as an ordered pair. So you could write it as x comma y. And the solution works in both equations. If the system has at least one solution, then it is a consistent system. And it is possible that the system has no solution. If it has no solution, then it's considered an inconsistent system. So we want to go about solving these. And so in order to solve them, there's different methods. So here is an example of a system. So we've got two equations, and we want to find an x and a y that works in both of them. So before we do this, let's talk about the different methods to solve. So there are there are more than three methods, but we're going to explore three methods. And we're going to say the first method is called the substitution method. And this is where we will solve one equation for a variable and substitute in that expression into the other for that variable we solve for. And we'll look at that. Another method is called the addition method. This is also entitled the elimination method in some books. So addition, you may have heard it referred to as elimination method. And this is where we will try to find opposite coefficients. And when we have opposite coefficients, we'll add the two equations together and it will eliminate a variable, and then we can solve for the remaining variable. And the third method that we'll explore is the graphing method. And with the graphing method, what you have to do is you graph both equations and you find where they intersect. So with the substitution method, let's start with that. We're going to take our equations. So this is our system. You'll see two equations. And we're going to solve for a variable. So let's write out the steps as we do them. So you can take either equation and solve for one variable in terms of the other. Best to pick the variable with a coefficient of 1 or -1. With coefficient of 1, and the next best one would be -1. So let's do it over here. So I'm going to go to my system. I've got the choice of either of these equations, and I see that this one has a coefficient of 1, this y. So what I'm going to do is I'm going to write this equation, and I'm going to say, all right, let's solve for y. I want to get y by itself. So there's this 2x here, so I'm going to subtract 2x from both sides, and I have y is equal to 4 minus 2x. And now I'm going to take that, and I'm going to go to the other equation. So let's write that down. I'm going to substitute the expression into the other equation for that variable. So other equation. So I'm going to take, let's see, this expression, and I'm going to go into the other equation, and I'm going to substitute it in for y, because I said y is equal to 4x minus 2. So I'm going to substitute that in for y. So let's write it over here. I'm going to say 2x minus 3, y is equal to -4. But in place of y, I'm not going to put y, I'm going to put 4x minus, or I'm sorry, 4 minus 2x. And now this equation has one variable, and I can solve for that one variable. So let's do that. I'm going to say 2x I'm going to distribute this -3 minus 12. 3 times 4 is 12, so -12. -3 times -2 is a positive 6x is equal to -4. And now I have some like terms I can combine. This is 8x minus 12 is equal to -4. And then I'm going to say, all right, I need to solve for x. So I'm going to add 12 to both sides. I get 8x is equal to a positive 8. And then divide both sides by 8 to get x by itself. I end up with x is equal to 1. And now I'm going to take that variable and do step 4, which is to back substitute it. Back substitute the value from step 3 into one of the original equations to find the other variable. Because we don't want to stop there. That's only part of my solution. I have x. I need x and y. And after I'm done with that, then I'm going to check my answer. And I have to check it in both original. So I'm going to go back to my original equation, and I got a value of 1. And that is equal to x. So in my two original equations, I'm going to take one of them. The one was 2x plus y is equal to 4. And I'm going to substitute in the value of 1 for x. I'll get 2 plus y is equal to 4. Subtract 2 from both sides, I get y equals 2. So those are my two answers. So my answer is, if I write it as an ordered pair, 1, 2. And I will take that back to my originals, and I will ask myself, does that work in both of them? So the originals are right here. So let's just write them up here. And what we're going to do is we're going to plug in the answer and make sure that it works in both. So wherever I have an x, I'm going to substitute in 1. I had an x here and I had an x here. And wherever I have a y, I'm going to substitute in 2. I had a y here, and I had a y here. And then I asked myself, are these two sides equal? And so over here I have 2 minus 6. Does that equal negative 4? And the answer is yes. So it works there. And then here I have 2 plus 2. Does that equal 4? And the answer is yes. So it works in both. So that is my solution. So that is using the substitution method. We can also use the other method that I mentioned, the next method, which is the addition method. So what I'm going to do is I'm going to take the same two equations, and now I'm going to do the addition method. And so let's give ourselves some room, and we'll start by writing the two equations. Same ones. The addition method says this. It says what you're going to do is first write the equations in this form. So you want them to write them in this form. So if there were, maybe one was solved for a variable, one was, you had x on one side of the equal sign, y on the other side, you're going to make them into this form. These are already like that, so we don't have to do anything. And then we have to look for opposite coefficients. I don't have opposite coefficients. Opposite coefficients would, like, this would be 2, and this would be negative 2. This would be negative 3, this would be positive 3. I don't have opposite coefficients, so I'm going to make them by multiplying one or both equations by a number. So I can make the 2's opposite here by multiplying one of the equations by a negative 1. So I could choose to do this one. That would make opposite coefficients. But when I multiply the equation, I have to multiply everything in the equation. So that means I multiply this term, and this term. I could also, instead of multiplying by negative 1, I could multiply this equation by 3. And that would give me opposite coefficients on the y. So I'm going to choose to do the negative 1 because that's easier. And I rewrote the first equation, and now I'm going to multiply that negative 1 out. After I do that, I'm going to add the two equations together. And I will end up with, this will be 0x, this will be negative 4y, and this will be negative 8. And now I solve the resulting equation. Negative 8 divided by negative 4 is 2. So solve, and then last step is to check. Now you're going to do that back substitution into either of the original. So I'm going to say, all right, I'm going to take 2x minus 3, plug in 2. So I took the first one here, and let's see what we get. We get 2x minus 6 is equal to negative 4. And that will give me 2x is equal to 2, or solving for x equals 1. Now I have my solution, and the last step now would be to check your answer. And you want to check it in both. And I just checked it in both. I know that this is the answer, so here's my answer. Using the substitution method, I get the same thing.